This video covers cell arrays and some useful functions that are associated with cell arrays. Regular arrays don't work well at all for strings, and we want to use cell arrays instead if we're using strings. Cell arrays have tremendous uses, but for right now we're just going to focus on putting strings in our arrays. When we go to create a cell array, we want to create it using curly braces rather than using square brackets. And if we want to overwrite an entry in a cell array, we also want to use curly braces to do this. But if we index into a cell array, we're going to index into a cell array exactly the same way as we index into a vector. So here I'm creating a very small cell array in MATLAB, and you can see that I'm using the curly braces instead of square brackets to create this cell array, and I've just entered in various strings, and if I hit enter, I can see what my cell array looks like. Now, as far as indexing into this cell array, it's identical to what we have with vectors. So if I want to see the third entry in cell array C, it's simply C parentheses 3, and I see no come back. If I want to see the first 3 entries in the cell array, it's C parentheses 1 colon 3, and that should give me the first 3 entries in that cell array. If I want to go back in and overwrite a value in the cell array, say I want to change that second entry in the cell array into a maybe, this time I, instead of using parentheses, which is what I would use for a vector, I am going to go ahead and use curly braces and say C curly braces 2 is equal to whatever I want to put in that second entry, which in this case I said I want to put maybe in, and that goes ahead and overwrites that entry. So this is a reference table of useful functions for cell arrays. String comp replaces the equal or is equivalent function that we use for numbers. Length, sum, and find translate beautifully to cell arrays. Last year we did an end-of-course survey in Models 1, and we asked several questions, but I've extracted the responses to 2 of the questions. One of the questions was about the videos. How often did you watch the videos? And the possible responses were always, often, sometimes, or rarely. And another question was gender, and the possible responses were female or male. If you want to take a look at these 2 cell arrays and play around with them, they're actually posted on Blackboard under Video Cell Arrays. I'm going to demonstrate a couple of things about these cell arrays using these key functions. So I'm going to load these 2 cell arrays into MATLAB by typing load video cell arrays. And I can see that both cell arrays pop up in the workspace. Let's take a quick look at those. First of all, just double click on videos. And you can see that the video file has the responses that we talked about, always, often, always. That none in the 4th row there means that somebody didn't answer the question, but we can see the various responses in that particular cell array. And if I double click on gender, I can see I've got male, female. Again, the 4th student that responded to the survey must have chosen not to answer this question, which explains why the none is in there. So suppose I want to count how many people said that they always watch the videos. I know that my key array function that I use in order to count something is my sum function. So let's take a look at that. So I'm going to use my sum function here, but notice inside the sum function I am going to use the string compare command because videos is a cell array. It's no longer an array full of numbers. So I'm going to use string compare to compare that entire cell array of videos to the response always, which is what I'm looking for. Again, that's going to produce a vector of logicals, trues and falses, ones and zeros. There'll be a 1 everywhere where the response matches always, and a 0 everywhere where it does not match always. If I add all that up, I will get the total number of students that responded that they always watch the videos, which in this case was 288. Now suppose I'd like to know the percentage of students that said they always watch the videos. Well, I just need to know how many responded always and divide that by how many people responded to the survey. I can see just by looking in my workspace window that since gender is 730 by 1, that means that there were 730 students that actually responded to the survey. I can also get that information simply by using the length command. So here I have the same sum string compare command that I had previously, and I simply divide by length of videos, multiply by 100, and we find out that the percentage of students that indicated that they always watch the video was about 39.5%. If I would like to know how many women responded to the survey, I can simply do a string compare between gender and female, and again the sum function allows me to count all of the occurrences, and I come up with a total of 113 women that responded to the survey. Now suppose I want to find the percentage of the women answering the survey that said that they always watch the video. This is where the find command really shines because it allows me to find the location of occurrences. So you can see here I have f equals find string compare gender to female, and ordinarily I would put a semicolon behind this because there's 113 women that responded to the survey, but in this case I'm going to go ahead and leave it off just because I want to show you what you get back. Alright, so I get a lot back, but if I scroll up to the top here, alright, what I can see is in the first row that corresponds to a woman that answered the survey, and if I look over here in my workspace I can see sure enough row 1 has female in it, but the next several rows have male, or that mysterious none. So if I go down a little further, sure enough I can see in row 7 I have a female, and then I have to go all the way down to row 30 to find the next one. So this find command gives me every single row in that gender array that has female in it. It's a great command. So now that I know all the rows that correspond to women out of the gender array, and I've stored all those rows in a variable called f, when I do my string compare with the video cell array to the responses always, instead of looking at the entire cell array videos, I do videos f. And that's literally going to look at row 1, row 7, row 30, and all the other rows on the list that corresponded to women responding to the survey, and it's going to compare those responses, how often do you watch the videos, to the response always. And if I run that command, I get 57.5% of the women that responded to the survey indicated that they always watch the videos. What about the guys? Well, I could do exactly the same set of commands changing female to male, and what I would find out is that it was considerably lower percentage. 35.9% of the male students indicated that they always watched the videos. Now take the quiz at the end of the video.